So my name is Gauthier Brier, so a bit of my background. I worked as a waveguide designer for a small startup in Finland, and after I joined Applied Materials, which is a really big semiconductor company, to develop some photonics application. And now I'm working for ATLANT 3D, so based in Denmark, to help them to promote and to develop the photonics application portfolio. And so today, I wanted and I would like to give you like some presentation about our product and about the offer of ATLANT 3D to the photonics market and micro optics market, and especially with some application in AR and VR. Okay, so let's go. So just a couple of words about ATLANT 3D. ATLANT 3D is a company which was founded in 2018. We are based in Denmark. We have a couple of entities all around the world. We are now more than 35 people. Yes, we are around like 40 people, and so we are targeting different kind of markets, but majority of the markets where we work are in electronics, emerging technology, and optics and photonics. And so, as you can see, we worked with a lot of great people, and we got funded by a lot of great people. Yes. So what's the problem? So from our point of view, when I started to join ATLANT 3D, we were trying to understand the problem, especially for R&D and fast product development. And in photonics and optics, something I started to realize, it's like on a pilot line or when we are trying to develop any kind of new optical components or optical devices, it takes a lot of time. Like typically, if you want to go to a proof of concept, it takes at least 1 year from my experience and from my expertise and from a lot of feedback I got from the industry. And mainly because the prototyping and because all the different steps that we use in the semiconductor manufacturing processes are really slow. And so what we are trying to address with our product and with our technology is to offer the possibility for the R&D and R&D group researchers and academics to kind of shortcut and to be faster. And so this is why we introduced this first product, so the Nanofabricator Lite, which is a product based on our proprietary technology, which is called DALP, and I will show you after. But mainly NF Lite is a ILD machine, which use spatial ILD and will help you to literally do prototyping and literally grow any kind of materials you need for your prototype. So how does it work if you are not familiar with ILD? You have different kind of ILD. You have the ILD which is spatial ILD, temporal ILD, where you will use cycle to mainly come to deposit different materials, so a precursor and a co-reactant. And when you do the cycle of precursor and co-reactant, you will be able to form a monolayer, and so you will be able to grow the material. In our case, we do not use temporal ILD. We use what we call spatial ILD, and so this way of using ILD is really great because you can pretty much do what we call local deposition, which means like as you can see on this video here, is that we use a nozzle, a micro nozzle, and inside this micro nozzle, you have different line of gases, and you send all of this line of gases of material at the same time, so the precursor and the co-reactant at the same time, and you are able to this time to grow the monolayer of material, not this time in the temporal domain, but in the spatial domain, because you will just apply a translation to form the layer. And so this is exactly what the video is showing here. And so why it's really interesting, it's because mainly you can do local deposition, so you save time if you don't need to, let's say, grow on an entire wafer. You can also think about like including your process into existing process line. You don't need to switch your entire process if you have already a components or a prototype. I will show you some example after. And so we strongly think that it's a good way for scientists and researchers and academics to shortcut in a way the patterning to develop some optical and photonics components. So what are the advantages to use this kind of approach? So mainly we are using a ALD based processing. So you have a huge portfolio of materials. And so mainly in my application, most of the time, I strongly focus on high refractive index material or material with uh, exotic properties, or also 3-5 materials. So yes, so mainly with ALD, you have like a huge portfolio of material. We can also control the material microstructure, and this is really interesting for our customer. Uh, I will show you one example at the end, but one of our customer, which is the University of Vermont, decided to buy our product because they were interested in the porosity of the material, and with our approach with the micro nozzle, we can mainly create structure where you can control and make an analysis of the material property really fast, such as the porosity. We have also the conformality that we can do pretty much easily with our nozzle, because we will be able to mainly grow the material inside high form factor, high aspect ratio structure. And so we couple all of that into our nozzle, all the advantage of ILD inside one micro nozzle. So this is exactly what we offer. Um, One thing which is really, really great with the micro nozzle and this approach that we are using is the fact that you can pretty much do gradient of materials. So you have this time when you use classical chamber of ILD in the market now, you cannot deposit different thicknesses locally. You need to use the same thickness, or you need to use other steps of fabrication to create a different height for your structure. Here with our nozzle, with our approach, you can pretty much use the nozzle and deposit layer by layer with some step, with increments, and so you will be able to deposit a gradient of layer. And so this is one example of the different gradients we can do. And so we started to realize that it's really interesting in many different areas of application, because you have the ability and you have the freedom of doing not only geometrical gradient, let's say, so with height variation or different shape, etc., but you can also study the property of your material, because you can pretty much change all the parameter of your deposition at the same time. And so this is some example of what we can do, but pretty much I really like this example of thickness gradient of this stereo tube, because you can um, you can use it to characterize your material really fast. And so another thing that we can do, and this is one example of why it's really powerful to use that approach, is that you can pretty much switch the different materials that you have in your micro nozzle, or your different line of gas inside your ALD, your DALP NF machine, and you will be able to deposit different kind of materials, but you will be also to deposit and to create different kind of sensors. And so here we are showing an example where we were able to develop different kind of sensors, such as glucose sensors and interdigitated sensors, and capacitors, and so this is pretty amazing for me, because when I joined ATLANT 3D, I was really mind blown by the amount of time that it took to do only those components. So pretty much for us, it took us only one day to print such kind of a wafer. Um, I have a PhD in photonics. I know how the struggle is to develop, like, some R&D prototype. And when I was working on metaspaces or on diffractive optics, it did not take me like only one day to print one component. So I think it's really valuable. And here you have like a great example of how you can shortcut all of this product development process and R&D process. And so one other example to showcase this is characterizing the TiO2 optical properties. And so you see, like, to generate only 50 data points with different thicknesses and temperatures, it took us only less than 5 hours of deposition and after some ellipsometry. So it's really fast. Some example of application I would like to underline here, and I was discussing about this just at the beginning, but when I say that you can use our product and put it like on your existing process line, or you can also integrate it to do prototyping on existing product. Here one example. So pretty much you can one of our customers, so the Silicon Austria Labs, came to us and say, okay, we have these MEMS mirrors and we need to deposit TiO2 everywhere except on those red patches. And unfortunately, we cannot do it with existing process line. Or we can do it, but it's really complicated. You don't want to break the MEMS, you don't want to break your samples and stuff. So they came to us and they say, okay, can you do that? And pretty much like we can do it pretty much easily. So we went on our software. We have a proprietary software where you can create the design and tell the nozzle and the machine where you want to deposit TiO2 with the different thickness if you want to play on the thicknesses. So here you can see the yellow, more intense yellow is like a higher thickness, and so we did deliver correctly to our customer, and it took us like not a lot of time to do this. Yes, and so some example of other applications that we have. One really great application is the one in the middle. So we started to realize that our technology was really good also to do seed layers for metal plating. As I was showing you, we can directly deposit on existing prototype or directly deposit on existing components. And so you can shortcut an entire process. And you can also do what we call the functionalization of nanostructure. And so here it was for gas sensor with different partners because we are working with a lot of different EU-funded project. And so here we were able to show that using our technology, we can pretty much come and increase the property of the sensor by depositing some materials. So yes, so some testimonials of the people we are working with. Um, and so this is some highlights where I think I was trying to gather all the different feedback of why I think this technology is really great for at least R&D and for researchers now, but also people who are doing a lot of prototyping. So mainly you can pretty much deposit a lot of material with complex material and thin film and interfaces with one stop machine. um, you can pretty much complete, and this one is really important. It's like you can see this technology as something you could play like alone, and that's all, or you can also integrate it to your process portfolio or equipment portfolio, and so you can use it to, you see here, make a functionalization of different structure. And here, this is the last one, but I think it's one of the main important one. It's like in some application and some area, you have some limitation with the lithography existing tool for a lot of people out there. And so Here we have like a strong testimonial of how our technology could remove some constraints and some barriers of existing process such as lithography.